Today we're talking about this question: how are decimals like fractions? So one way that decimals are like fractions, or fractions and decimals are the same, is that they're both rational. What rational means, or rational numbers are they are any number that can be expressed as a fraction. So there are some numbers that can't be expressed as a fraction, and we'll talk about those later on in the school year, but for now, if it can be expressed as a fraction, then it's a rational number, and all fractions and decimals are rational. So that's one way that they're alike. So here are some common decimals and fractions that we see on a regular basis. We have a number line here that's broken up into fourths, and we've labeled those fourths. 1/4, 1/2, which is the same thing as 2/4, and 3/4. Now, I've also listed their equivalent decimals. So 1/4 is the same thing as the decimal 0.25. 1/2 is the same thing as 0.50, and 3/4 is the same thing as 0.75. Here's some other examples. Again, now I've broken this into thirds, and these are some common fractions as well. 1/3 and 2/3 are very common fractions we'll see, and their decimal equivalents are 0.33 or 0.3 repeating, and 0.6 repeating or 0.66. And one last set. Here is another one. This one is broken up into 5 segments or fifths. And we see we have 1/5, 2/5, 3/5, 4/5. Obviously right here at 1 would be 5/5. And the common decimal equivalents of those are 0.20, 0.40, 0.60, and 0.80. We'll see those fractions and decimals, all these common ones, we'll see them a lot in our everyday lives. So here's the question though. Why would we ever use decimals over fractions, other than just we hate fractions? Well, there actually is a practical application for using decimals over fractions. Let's take a look at an example. So let's say I have this equation here, 3/5 plus 4/10 plus 14/15. If I actually solve it out, I would end up with the answer 58/30. Well, this is kind of hard to understand. 58/30, I can't really comprehend what that value is. It's a crazy fraction, and I'm just left puzzled. But if we convert all of those fractions into decimals, 3/5 into the decimal 0.60, 4/10 into the decimal 0.40, and 14/15 into the decimal 0.93, we add those up, we end up with 1.93 instead of 58/30. This is much easier for our brains to comprehend, to really assign value to that. I can think of this as, well, that's $1.93. So I kind of understand that when it's put in sense of decimals, as opposed to this crazy fraction. So how do we convert fractions to decimals like I did? Right here, I converted 3/5 to 0.60, 4/10 to 0.40. How did I do that? Well, let's go ahead and take a look, and I'll show you the steps here. So let's say I have the fraction 3/8, and I want to convert that into a decimal. Well, every single fraction is just a different way of writing a division problem. It's always the numerator divided by the denominator. So I can reset up this fraction as a division problem, which is 3 divided by 8. Now I can solve this to figure out what the decimal equivalent of 3/8 is. So I'm going to go ahead and solve this out real quick. And so 8 does not go into 3, right? 3 divided by 8, well, 8's too big. 8's bigger than 3, it doesn't go into 3. So what I have to do is I have to start using a decimal point. So I'm going to add a decimal point there, and I'm going to add one to my answer because I'm saying that 8 goes into 3 less than 1 whole time. So we're getting into decimals here. And I'm going to add a 0 here, okay? So now I'm working in the tenths place, and we'll go over this in just a bit. But for now, I'm working in the tenths place. I'm trying to figure out how many tenths does 8 go into 3? Well, I can do this by saying, how many times does 8 go into 30 without going over 30? Well, I know that 8 can go into 30 3 times without going over 30, and 8 times 3 is 24. So now I have accounted for 3/10 of 8 that goes into 3, and I'm going to subtract 24 from 30 to find out what's remaining or what's left over. And 24 minus 30 is 6. So now I start the process over again. How many times does 8 go into 6? Well, wait, it doesn't. 8's bigger than 6. So I'm going to come up here, add another 0, and I'm going to drop it down. Now I think about how many times does 8 go into 60? Well, it goes into it 7 times. And 8 times 7 is 56. Then I subtract to find out again what's left over. 60 minus 56 is 4. 8 does not go into 4. I need another 0. And I drop this one all the way down. How many times does 8 go into 40? Well, it goes in exactly 5 times. 8 times 5 is 40. I subtract to find out what's remaining. And this time I see, well, there's nothing remaining, so I'm done. There's my answer, 0.375. And this answer can be read as 0.375 or 375 thousandths. I could round it down to 37 hundredths or 3/10 or 4/10. I want to point out though that now that we're on the other side of the decimal point, we're no longer talking about whole numbers, we're talking about decimal numbers that have a value less than 1. And so this place value right next to the decimal is the tenths place, the next one is the hundredths place, next is the thousandths place. Really, the thing to remember here is that each of these place values are going to end with a THS.